Hey everybody. This is just a quick update basically on quarter 3 week 1 content with the Lego project and some of the things that have kind of come up since we last talked on Wednesday. So in the slideshows, directly in the slideshows, we kind of broke up, we being Katie and I, of course, kind of broke up some of this stuff to make it a little bit more understandable, a little more clear within the project. So we broke up, as you can see here, what don't you like, and then basically go into what the project is. So in this project, you will be using reverse engineering to add an attachable enhancement to find this. They watched the video. And then we brought in kind of and broke down what the problem is and what the task is. So the problem itself is the Lego is trying to get more kids interested in their products and reach kids who actually or don't currently buy their products. The task is to design a new Lego set to entice kids to play with Legos. You must first use and build an existing product or model using Legos, then design an attached enhancement that will make the Lego set more appealing for kids. The next slide, we go over our constraints that kind of revolve now around just, again, more clear. It was all in the Lego project details, but we want the kids to really understand what this project is and what they can and can't do right off the bat. So we also changed the Lego pieces requirement to 20 piece basically minimum. You'll see here that the attachable enhancement part can be no larger than the original module. That's always been a thing. And then the last one is the attachable enhancement part it can be multiple pieces, right? And then I broke down this 4-step process. So this is what the project you have to do or the students have to do within the project. It's really detailed down here in the notes. But basically, step 1, physically build an existing product model. Train, keyboard, T-Rex, something like that. Does not have to be that. It can be whatever they want, but it has to be an existing product or model. Second step is to virtually build existing product model using the Mechabricks. Export the product is the third step from the virtual to the Onshape. 4, design the attachable enhancement in Onshape. And then what I kind of did was I rearranged this. So now I gave an example. I made the train physically. I went into Mechabricks. I converted it into Onshape, made an attachable enhancement, right? I talked about what the existing product is, what the problem is, and then what the attachable enhancement is because of that problem and what it does to solve that problem. I then went into and literally broke down each step. Step 1, I physically built an existing product. Step 2, I virtually built the existing product using Mechabricks to create your product or model. And we'll go over that later in Criteria C, but just a heads up. Criteria number 3, export the product or model from Virtual World to Onshape. And this is what it looks like as a mesh going into Onshape after you export it. And finally, design attachable enhancement in Onshape. You have to design, and this is where the big hiccup came, you have to design the attachable enhancement directly onto the exported file. And what I mean by that is when you bring in the train, for example, here as my example, it'll come up as you can see over here, an import. Well, the problem with that is it's a part studio, but it's not a physical part. It comes in as a mesh. And that's a big problem because you cannot use meshes in assemblies. I've tried everything. I've researched it like crazy. It's not possible through what we have virtually. So as far as Chromebooks and all that kind of stuff, we can't do it. So the workaround, and this is where I was kind of talking about, and this is why all this is being updated and fixed. You're going to have the kids make the parts of this attachable enhancement directly onto that import. So they import it and they go right into sketching and start making the product into that. And you'll see now that I have the 6 parts that I made as the attachable piece, as well as the mesh down here that I can take off and put. And it's kind of nice. They can use it as a reference. The problem with that is then they can't make an assembly. They can't make a bill of materials. They can't make an exploded view. They can't do any of that. But it's okay. We've kind of revamped this. So keep going on the presentation. Now example 2 and example 3 are the students lifting. So I gave them an existing product or model. They're going to come up with, using these 2 Jamboard or a Jamboard, come up with a problem that they see within this, right? A hypothetical problem. My example was the T-Rex is very vulnerable on his back or her back. So what are some problems? Again, they need armor. Then that's the attachable thing. They're gonna make armor around there. A keyboard, for example, in this one, right? What's the problem? Well, it looks like it's really thin on the back. I'm making this up. Thin on the back, and every time I play it, it tips forward or tips back. So the attachable enhancement would be some kind of weighted system that they're putting and attaching onto the back. Have the kids go through this. Go through their ideas, their brainstorming, and figure out and explain basically what's good and what's bad and what would work and what wouldn't work. So that's their heavy lifting. And then talk about basically the roundup of, it's very important that before your interview, they have the existing product or model in mind, ready to go, and the research you perform will be surrounded around the enhancement. So you plan on making to the above product, right? Katie thought it was a good idea to make this kind of slide. So this walks through criteria A, B, C, and D of the whole entire project, what it would look like, really bare bones, just to give the kids an overall look of what the project entails. If I scroll all the way down to the bottom, Katie made this awesome slide that basically breaks up what the kids need to have done for and what they should be researching in criteria A, right? Primary sources, learn about Lego. Secondary sources, why should Lego market to more kids? What's wrong with Legos that already exist? What's already out there? And then write the design brief and make sure that they design their base model or have it ready to go by that interview right there, right? That's it for this topic 50. 52, the only differences really in here, we added a couple slides to go over what the brainstorming checklist should look like. Brainstorming 3 attachable enhancements. Remember, the attachable enhancement cannot be larger than the original model. You will not have you will not have to physically build the enhancement out of Legos, and the enhancement does not have to be one piece. It can be multiple pieces, like we talked about in the armor. She, being Mrs. M, also added a slide here on 11. She is having a lot of problems with her decision matrix and kids not doing the annotation and labeling as well in their modeling and their brainstorming. So we added a couple slides just to kind of reinforce this. This is an example from the flat to 3D annotation, labeling. A lot of kids are not doing that. And then she also, her decision matrix or matrices are struggling a little bit. So she also put this in here to kind of show an example of what a good one would look like. And then just IDing or identifying the ideas and the criteria that the kids are having to make. We're still having some problems with that. The changes in the Lego project details are all obviously here. I've updated A, B, and C. C is the big one that's a lot of changes because now we're not doing an assembly or an exploded or a bill of materials or any of that kind of stuff. They're going to be going through and saying, what was the plan? Create a Mechabricks version of the original product. Create an Onshape part studio of original product by exporting into Megabox model. Create an attachable enhancement directly into the part studio you created above. Create a drawing file with overall dimensions for the final design. That's it for drawing files. They're not going to be able to do any of the other stuff. And this is a quick project anyways. It's okay. We're really going to hammer that stuff home in Automata. So we didn't see that was that needed to do any of the other assembly stuff here. So use the Criteria C guide, and then what modifications they make. Criteria D stays the same. I hope this helps. And again, I know you guys are going to have some questions or feedback or any of that kind of stuff. Please just hit me up whenever you guys can. And I will talk to you then. Thanks.